Welcome and welcome back. We're here to introduce you to the sky, the stars, the planets, much as if we were sitting around a campfire looking up, or as originally planned in a small group at the Queen Elizabeth Planetarium. Do a little bit of talking and then step outside to point at the real sky. Until then, we're resuming. First and foremost, this is all about looking, what you can see with your eyes. No telescope is required. Binoculars are great if you have them. We will not be covering black holes, dark matter, dark energy, or any of that fancy stuff because those are typically talked about at our monthly meetings, which of course you're all welcome to attend. I need to keep saying the following. It's really crucial for you to make a point to step outside every clear evening, even if just for 5 minutes, to just reinforce the names of the brighter stars and identify the major planets. And it just absorbing it allows you to see more and remember more as the months tick by. Berta and I have tried to design these sessions so that you can enter the loop at any time without being overwhelmed or having to catch up. Concepts will generally repeat on an annual cycle and help you achieve the certificate and pin Explore the Universe, a free welcome program from the Royal Astronomical Society of Canada. Please download and print out the PDF. That's all these key publications and links are on the web page for this Zoom series. The Royal Astronomical Society of Canada is our parent organization, a non-profit group of 5,000 more amateur astronomers, mostly amateurs, and a handful of professionals dedicated to the advancement of astronomy and allied sciences. The Edmonton Center here has 300 plus members, we hold monthly Zoom meetings, as I just mentioned. So we have a Facebook group, which you're more than welcome to join, and also an email chat list. And then if you can't get enough fast enough, then please check out the links that are on the webpage for more introductory sessions that have been recorded by our national group. Please interrupt me if you hear a word that you don't understand or a star name that you're not familiar with that I haven't explained. And so I try and remember that I too started out knowing very little. Okay, with that, let us switch over. Of course, the screen is in the wrong side. Oh, yeah, that's good. Get rid of this one. And yeah. Okay, and one of the nice things that I love about August and September is that the sky gets darker earlier. And we'll be talking a little bit more about that in a few moments. Tonight, we'll be talking, as usual, a little bit about the satellites, the International Space Station, and then we'll talk about what's up in our sky, in particular Sagittarius and Aquila. Berta will talk about the moon, some deep sky objects, and then I'll talk a little bit about why our sky changes so fast in spring and very little in fall. So with that, when you look up in the sky, you might see a fairly bright object moving slowly with about the speed of a high-flying airplane, apparent speed as it crosses the sky. And this will more than likely be the International Space Station. So it just leaves a little streak. Right now, it's doing morning passes, so 5 a.m., 4 a.m. So unless you're out early walking the dog, you're not going to see it until mid-September. And then we get into a nice series of evening passes. I've mentioned here, these predictions come free at heavensabove.com, and just make sure you tailor it to Edmonton as your location rather than the equator in the Atlantic Ocean. And so this tells you roughly where to look, how bright it's going to be, and when all the passes are. Sometimes you get 2 passes in one night, about 90 minutes apart or so. So here we go. Looking south, Friday night at 9:15 p.m. on September the 17th, I think it was. And this is the path that is forecast for the International Space Station to move along. The moon will be rather bright, quite close to the bright beacon that is the planet Jupiter. And just off to the right, the next brightest star, just over a little bit, is the planet Saturn. So they're about as well placed as they're going to be for the rest of the year. And the Jupiter's bright enough that you might mistake it for a plane coming into land at the international airport. It's that bright. But it sort of doesn't seem to move, except it's along with the sky. So as we're looking south, the center of this map, which you can download from the web page that features this Zoom meeting, overhead is the middle of the map, but we're going to focus here on mostly looking south to up. And here is the summer, what we call the summer triangle. It'll be the first stars to come out after you see Jupiter. Click here. And so essentially these are the first 3 stars that almost everybody getting into astronomy learns, because typically they get in, start doing their astronomy in summer. And so their first introduction to the summer stars is this lovely, bright, just aptly named, simple summer triangle. Deneb is the star off to the left. It's part of Cygnus, which in the city, this is the eye of the swan, Cygnus, the swan that this is a part of. Vega is the nice, bright blue-white, pale blue star high up, and Altair. So it's Vega, Deneb, and Altair on the summer triangle. And then low down is a little to the east of south. We have Jupiter and Saturn. So these are actually 3 different constellations: Cygnus for Deneb, Lyra, which is a tiny constellation up there, and Altair as part of the Eagle, which we'll get into shortly. Altair itself is 16.7 light years away, so relatively close. The closest star being Proxima Centauri, Alpha Centauri nearby. That's 4.3 light years, so only 4 times farther out than the closest star is Altair. And it's about 10 times more luminous than the Sun. And its name is actually loosely called the Eagle, which is its constellation. So Aquila, the Eagle. Many cultures see this as some form of eagle or falcon, and it's the reason is fairly plain to see. You have a bright star where the eye might be, and these wide outspread wings, the center of the body, and then this little curving tail down here. So just a nice bright one. I suppose places that have a lot of butterflies might have called this a butterfly constellation, but the ones that come down to us from the Romans and the Greeks is an eagle. I think it's neat here that Ag-juk in Inuit is sunbeams heralding the return of the sun. In the depths of winter, Altair is quite low to the north, and then as it starts to come back up, it is always the hope of spring returning and light returning. So it's quite important for the Inuit. And the dark sky is really the place where Aquila literally starts shining. The bright stars, this nice little triplet at the front. The Milky Way, as you can start seeing in the background, courses right through it. One of the dark lane here is galactic dust and gas, a gas that's not lit up and shining, but just dust that is obscuring all the stars in behind. And just take binoculars and look all over the place. There's a little dark blob here that's called Barnard's E, because it's in the shape of a capital E. And then this area is now actually into scutum, but this is called the scutum star cloud, and it's just a very rich area of stars. But all over the place here is just marvelous binocular fields. So I encourage you to, once the moon gets out of the way, so another week and a half or so, the moon will rise well after midnight, and then you're primed for seeing this out under a nice dark sky. Okay, the other constellation that we're featuring is Sagittarius, and the Greeks give us a half horse, half human. I don't know how anybody sees anything closely resembling that, but to just about everybody I've ever met, at least in North America, we look for and call it the Teapot, or the Teapot in Sagittarius. So it's this little group of stars down here, which I'll zoom in on in a moment. So close up, this is your Teapot. There's another star that's just down below as it gets dark. And so, yes, it does look like a teapot. Nice classic handle, little china roof lid, and away you go. And then poetically, the Milky Way cutting through here looks like steam coming out of the spout of the teapot. There's under dark skies, you will see very obvious to the unaided eye, and again in binoculars, you'll see what's called the Sagittarius star cloud and the Lagoon Nebula, which Berta will be talking about briefly. Another little funny thing is that, well, if this is a teapot, then this here has to be a teaspoon. But it's not an official constellation, and actually both of these, the teaspoon and the teapot, are what we call asterisms. So it's not an officially recognized constellation, but it's just a star pattern that people see, so we call those asterisms. And that, I believe, is the introduction to the Teapot, and we'll let Berta cover the Lagoon Nebula after she does the moon. So over to you, Berta.
Okay, so now continuing with the Explore the Universe certificate, Alister has covered the first part of the objects to see, which are stars and constellations. Now I'm gonna go to the second section in the Explore the Universe certificate, which is the section that deals with the moon. And so every month we feature one of the Maria and one crater, so that they can be observed by people. The Maria are normally can be seen good when you have full moon, and again with binoculars, and sometimes for some people even with by eye you can see the bigger ones. So the Maria feature this month is Mare Tranquillitatis, okay, which is can you please sorry, I was gonna hover my mouse, but of course it's Alister's. Yeah, thank you, Alister. So Alister is pointing out that Maria in there. So Maria are just in a nutshell, they are impact craters that happen at the very beginning of the formation of the moon. And then lava came from under the moon, triggered by the impact crater, just basically triggered an explosion of lava coming from inside and created this area of basalt rock that is a little bit darker than the other areas of the moon. And that is what we call Maria right now. It's just areas where the main rock is basalt. And so this basin in particular is around 880 kilometers across, which is comparable to the Black Sea here on Earth. And Maria Tranquilitatis is one of the most famous one, maybe the one that most people know, because that's the place where the Apollo 11 landed with the first 2 men to land on the moon. It's somewhere down there, actually, kind of down. I mean, obviously you wouldn't be able to see it with the telescope. You couldn't see the rover that they left in there. Or I think the rover is in another place though. Sorry, that's my, yeah, thank you, Alister. Yeah, the rover is not there. I think they landed somewhere else. But anyway, that's where it landed. The astronauts Neil Armstrong and Buzz Aldrin landed the Eagle module in there, in this mare, and took the very first steps on the surface of the moon in there. Now, any question so far? If you can go to the next slide, please. Oh, I think it's the previous one. I think we skipped, yeah, there we go. So as I mentioned, the Maria are probably best seen in, Maria Tranquilitatis, you can see from first quarter and on, it will just be there. But yeah, with full moon is a good time to see most of the Maria. But when we are talking about craters, the best time to see them is at very specific times when the terminator, which is the area between day and night in the moon, this line that Alister is pointing out, that separates the area with light versus the area with night. So when the terminator is close to that crater, it creates these areas of light and shadow that highlight the height and the depth and make the crater very, very visible. So if you were looking for this crater in full moon, it would be really difficult to see because it would be completely washed out. It would be just kind of like a flat feature on the surface of the moon. But when you look at it, when the terminator is close to it, it's very easy to see. And that means that to looking for this crater, which is Theophilus, the one that we are featuring today, the best time to see them is when the moon is between 5 and 6 days old. That is to say, almost first quarter, just a little bit before first quarter. That's correct. When we measure the days of the moon since new moon. So after new moon, as the moon starts waxing, you count day 1, day 2, day 3, day 4. So this is between days 5 and 6 after the new moon is the best time to look for this crater called Theophilus. This crater is a prominent crater that also has a central peak. It can be very nicely seen in the picture, which is around one kilometer tall. It also has 2 other craters that are pretty impressive and visible, Cyrillus and Catarina nearby, so I highlighted them too. And best view of this crater, as I said, is between 5 and 6 days old. And it's an interesting crater because it has a mountain in the middle, a peak in the middle, and you can see the shadow here in the picture. That is actually a tall crater. Thank you. If there are no more questions, yeah, this is just a picture taken by the Lunar Orbiter 3. As a side view of this crater, you can actually see the central peak very nicely on the walls. Yeah. Thank you, Alister. Next slide, please. Okay, so if there are no questions about observing the moon, now we are just past full moon, so we still have to wait around 15 days to get back to day 5 and 6, more or less. But anyway, The next section in the Explore the Universe, past the moon, is actually the planets, but we're skipping that. Well, Alister has mentioned that you can see Jupiter and Saturn towards the east, low in the sky, southeast these days. And so the next section in the Explore the Universe certificate talks about deep sky objects, okay? And it has a list of objects to see for different seasons. And so for this month, we have chosen the Lagoon Nebula in Sagittarius, which is named M8, and is, you know, Sagittarius is the teapot that Alister had just mentioned. It's very low in the southern horizon right now. You have to have a good horizon to be able to see it. I certainly cannot see it from my backyard with trees and garage and everything. So Sagittarius is always incognita for me, but it has a lot of beautiful, beautiful objects to see. And one of these is this Lagoon Nebula. This nebula is an emission nebula. And emission nebulas are clouds of ionized gas that do emit light at various wavelengths. So this basically is a cloud that shines in the sky. And they shine because they get their gases, the gas that makes that cloud is ionized due to the photons emitted by nearby stars. And that makes they excitize the atoms, and they, when de-excitize, they emit light, and therefore we can see these clouds of light. And the Lagoon Nebula is one of those. And it's really beautiful because it does this a huge cloud of gas that is bisected at one end by a dark lane. And it's around 4,100 light years away. And an interesting feature that obviously you won't be able to see with binoculars is that new stars are forming in this nebula. The stars are forming when there are gas clouds like this, which are sometimes remnants of another star that has died before. And so we know, we are almost certain that new stars are being formed in this particular nebula. Next one, please. And another interesting object that we thought it will be, it's a different thing, is a globular cluster. We talked in the last meeting in June about globular clusters. I think it's just basically, they are big balls of concentrated stars in a group. They are very, very old, these globular clusters. They are normally as old as the galaxy, and they kind of hover over it. But they are, of course, gravitationally bound to the galaxy. And so this M22 this cluster is almost a magnitude brighter than the very well-known M13, which is a globular cluster that we featured in the last meeting that we did. And you can also look for a nebulous disk, which is around 2 degrees northwest of the Teapot. And so sometimes globular clusters, depending on the from binoculars, you basically looks like a ball of light. It's like a fuzzy patch, which is round, and it's around 10,000 light years away. And M32 was one of the first globular clusters to be discovered in 1665 by Abraham Idle. And then later on, it was added to the Messier catalog by Charles Messier, but he was not the one who saw it first. Next slide, please. And so now that we have, there are of course a lot of different DSOs, dark sky objects listed in the Explore the Universe certificate. Most of them can be seen with binoculars from the city, although the Lagoon Nebula, I will recommend trying to look at it from outside the city, I will say, because nebulas are something that are hard to see from the city, unless Alister or Abdur correct me if I'm wrong, but I will say the globular cluster you can see it from the city, but I will say the nebula probably not. As I say, I don't see Sagittarius from my backyard, so I cannot look it look at it from my backyard. So the next objects that come in the Explore the Universe certificate are double and multiple stars. So this month, again, we are highlighting actually two of the most famous double stars in the sky, which happen to be in the southern sky, very close to the summer triangle that Alister has mentioned before. So the first double star that we wanted to mention is what is normally called the double-double. So when you hear someone say, oh, I saw the double-double, it's this double star. Because it's, if you see Vega, which is the very bright bluish star up in the sky close to the zenith looking south, just very next to it, there is this epsilon star that if you look at it with the binoculars, you immediately separate it in two. You will see that there are two stars in there, where in the area where is epsilon in the picture. And if you further look at it with a telescope, you again can split each one of these stars into two more stars. So at the end, you end up seeing 4 stars. Okay, so that's why it's called a double-double, because it's a double of a double. So it's 4 stars. It's around 162 light years away. And we know that it's actually a multi-star system of at least 5 stars, but you can only see 4. So the widest 2 components are easily separated with binoculars, and they do orbit each other. So they are orbiting binaries. So these stars are bound together. Sometimes some double stars are just stars that happen to be in the same place in the sky from our point of view, but they're actually not related to each other. But in this case, these 2 stars are actually gravitationally bounded to each other, and they are spinning around each other with a period of over hundreds of thousands of years. And when viewed with a telescope, each of these 2 stars proves to be a set of, again, 2 stars, as I mentioned, and these ones are very close orbiting binary stars too. Close orbiting stars, sorry, I shouldn't have written binary in there. So it's a beautiful sight to see. Yeah, thank you. And the last star that we wanted to mention this month is Albireo, which is, I guess, one of the most famous stars to look at in the summer. And the reason for that is because the 2 stars that make this system have very different colors. I have taken this picture of it from Wikipedia, and you can see that one of the stars is more blue, and then the star that is a little bit more brighter of the pair is yellow. And if you look at this with binoculars, you can certainly see the colors, and if you look at it with a telescope, the colors become way more apparent. It's one of the most beautiful double stars in the sky. It's in the constellation Cygnus, so it's the swan that we've been mentioning. So you have Vega, the star Vega from the constellation Lyra, and then you move to the Cygnus, you move to the Neb, that's the tail of the Cygnus, and Albireo will be the head of the swan, the Cygnus, the swan flying across the Milky Way. So Albireo makes the head of the swan, and it's you should use tripod mounted binoculars, because if you're looking at it with binoculars handheld, maybe the shaking makes the stars come together. So in order to see them nicely separated, you probably should mount your binoculars in a tripod, but other than that, you should be able to see them. And I think I'm done with my section, unless there is any question from anyone.
Okay, thank you, Berta. Yeah, there's, and again, even in the city, if you scan along here with binoculars, especially if you go from to the left of the summer triangle into the summer triangle and to the right a bit, you'll just see there's just so many more stars here, and that's right along the Milky Way. Even from the city, it's just a very rich area. Okay. There we go. Whoops. Jumping ahead. Uh-oh. There we go. Okay. So I like to call this forever fall skies. Fall, autumn is probably in the northern hemisphere is probably the best month or time of year, including early October, to be observing. The sky finally gets dark at a reasonable time, and the summer Milky Way is still very prominent. And it just seems to hang around right until we finally hit winter. Whereas spring, once you get used to doing a little bit more astronomy and start looking at objects and galaxies in Ursa Major and Coma and Virgo, they just seem to whiz by. So why does that happen? So we're going to have a look at this. Okay, so this diagram is from Guy Ottewell's Astronomical Companion. I love this book. It's an oversized large book. It's almost 11 by 17. It's a huge drawings. Anyways, so here we are looking down towards the sun at an angle onto the flat plane where Earth, this is the position of the Earth here, these asterisks. As you can see the dating here, September 1, August 1, July 1, June 1. So that would be the orbit of the Earth around the central sun. And if you just imagine the stars just beyond the Earth's orbit, of course they're a lot farther, but to our eyes, just looking at the sky, they look immediately outside of the Earth. And most of you will know that from sometimes reading horoscopes that there are 12 zodiac constellations. And the zodiac are the constellations that the sun appears to move through. So very famous constellations like Leo, Cancer, Gemini, Taurus, Aries, Virgo. Ophiuchus is one of the places that the sun does go through, but is not recognized by the astrologers. Anyways, so the point here is that as it takes 1 year, of course, for the Earth to go around the sun. That's how we defined the year. And there's 360 degrees in a circle. And so we have, it's no coincidence, we have 12 months and 12 zodiacal constellations. And so doing a little bit of math for you, each month is 30 degrees of the sky. And so what ends up happening is that as the Earth moves from here, July to August, that will be 30 degrees. And so the sun, looking where the sun is, the sun would move from one constellation to the other. And when we're looking out away from the sun, at this time of year, as we get closer to September, we're looking towards Sagittarius, so backwards here because we're looking through the sky, but we'll be into Capricornus and Aquarius. And then a month later, we'll have shifted and we're looking away from the sun at night, and we'll be looking at a different part of the sky. So the other thing, of course, is that one Earth day is how long it takes for the Earth to rotate, make a complete cycle. And so that too is 360 degrees, but we do it in 24 hours. And so it turns out that one constellation is about 2 hours of time. So you can actually estimate the passage of time as you watch constellations cross the sky. So roughly one of these main constellations is going to take 2 hours to cross the south, for example. And so to our eyes, it's, if you look at the sky once a month at 8 p.m., you'll have noticed that what is facing you due south has shifted by one constellation. I'll show you that right away. So here we are looking south. I've chosen winter here. We are December and to January. And here's the Great Square of Pegasus. To the south, the circlet of Pisces. Here's Pisces. This Pisces is quite obscure in the city. You might be able to just pick out this little circlet. But Aries is here. Aries I just look at it as a hockey stick, and it's quite prominent even in the city. You can pick out this hockey stick. So from one month to the next, you can see how Aries has shifted from just off the side to straight south. And in one more month, if you look south at 8 p.m. in February, Aries would be off on the right-hand side. So things just once a month, one constellation. Now, the interesting thing is when you start getting towards spring. So here we are, March 1st in the evening. We've got the fantastic Orion constellation with its prominent three-belt, equally bright stars pointing to the brightest star in the sky, Sirius. So a magnificent part of the sky in February through March. But then if we shift exactly 1 month later, sure enough, you can see Procyon here entering on the left is now center stage. But the problem is that, it's no longer dark. So 8 p.m. on April 1st is, it's not dark. So you can't even see these stars. So you have to wait a little later for it to get dark. And now here's the comparison where Procyon, rather than being in the center 1 month later, once you actually add the time for it to get dark, has now shifted all the way over to the other side. So in spring, the sky seems to move about 1.5 constellations every month. And of course, this gets worse as you head into summer, because again, the sky is lighter still as we get into summer, and you wait for it to get dark, and you have to wait till 10 p.m. or 10:30, 11, and before you know it, constellations like Leo are already shifting and starting to set. Now in fall, it's the reverse happens. The skies get darker earlier as we head into winter. And so here we are, September 1st, in just a few days. And here's the summer triangle from Deneb, Vega, Altair. Deneb, Vega, Altair. Just keep repeating those, and you'll know those names for the rest of your life. And so 1 month later, it's quite well, as you see, it's 10 p.m. here for darkness, the same amount of darkness, 8:40 p.m. So as the sky gets dark, here's the summer triangle that's still almost due south. And then another month goes by, and here's October from the previous chart, summer triangle, and you hit the start of November, and the summer triangle is still there, just shifted over a bit. So it still seems to hang around. There's Jupiter and Saturn still slowly making their way across. And then even when you go from November into December, well, the summer triangle is still there. Vega is just off the screen here. But notice Altair, it's just moved over a little bit. So essentially fall seems to hang around for 4 months. So especially for deep sky observing along the Milky Way, the rich Milky Way, through here is just fabulous. You've just got all the time in the world to look at the nice star clusters and gas clouds in the summer to early fall Milky Way. And then in the spring, poof, your galaxies just go by really quickly. And that is that. So I'll just back up here to leave something a little more interesting on the screen, and we can, I'll just stop my screen share for a moment here. We can go back into gallery view, and if there's any questions, you can pop back into the share screen and call up one of the diagrams. Any questions, feel free.
No question, but that was very helpful. Thank you, Alister.
Yeah, I didn't know myself about why it's true. I probably haven't even noticed that it's true that the summer triangle stays there forever and ever and ever. Now that you say it's true. And especially the summer Leo constellations, they just whip, yeah. So it's a latitude dependent thing, of course, because as you go south, then the time, the difference between day and night won't be as pronounced as it's in here. And then you won't see that effect. Yeah.
Yeah, exactly. Yeah. As you get towards the equator, it's sunset is sort of just after 6 o'clock year round, and yeah, the constellations move. But yeah, the farther north you are, the stronger that lasting effect, and the faster the spring sky goes by. Oh, and while I'm got the mic here, just a reminder that in 1 week's time, Jeff Robertson, who's here, will be presenting What's Up in the Sky this month. So he'll be, I'm sure, talking about Jupiter and